The AMD K6 and FX-8350 are two processors that were designed for different eras of computing and faced different challenges in their respective markets. In this section, we will compare and contrast these two CPUs and see how they stack up against modern Ryzen CPUs. The AMD K6 was launched in 1997 as a competitor to Intel's Pentium II. It was based on the NX686 microprocessor that AMD acquired from NextGen, and it used a dynamic instruction reordering mechanism to improve performance. The K6 was compatible with the widely available Socket 7 motherboards, which gave it an advantage over the Pentium II that required a new Slot 1 platform. The K6 also had a lower price than the Pentium II, making it an attractive option for budget-conscious consumers. However, the K6 also had some drawbacks. It had a smaller cache size than the Pentium II, which limited its performance in some applications. It also had a lower clock speed than the Pentium II, which meant that it could not match its raw performance in some scenarios. Moreover, the K6 faced stiff competition from Intel's Celeron processors, which offered similar performance at a lower cost. The K6 also struggled to run some newer games that required 3D graphics acceleration, which the K6 lacked. The AMD FX-8350 was launched in 2012 as a part of the first native 8-core processor series. It was based on the Viscera architecture, which was an improved version of the Bulldozer architecture that AMD introduced in the FX-8350. Had a high base clock speed of 4.0 GHz and a boost clock speed of 4.2 GHz, which made it suitable for overclocking enthusiasts. The FX-8350 also supported DDR3 memory up to 1866 MHz and had a large L3 cache of 8 MB. However, the FX-8350 also had some drawbacks. It had a high power consumption of 125 W, which required a robust cooling system and a high-end motherboard. It also had a low IPC, instructions per cycle, compared to Intel's Core i7 processors, which meant that it could not perform as well in single-threaded or lightly threaded applications. Moreover, the FX-8350 faced fierce competition from Intel's Ivy Bridge and Haswell processors, which offered better performance, efficiency, and features at similar or lower prices. The AMD Ryzen CPUs are the latest generation of processors from AMD, launched, and they are based on the Zen architecture, which is a completely new design that aims to overcome the limitations of the previous architectures. The Ryzen CPUs have a high IPC compared to the FX-8350, which means that they can execute more instructions per cycle and deliver better performance per core. The Ryzen CPUs also have a lower power consumption than the FX-8350, which means that they can run cooler and quieter. The Ryzen CPUs also support DDR4 memory up to 3200 MHz and have a large L3 cache of up to 32 MB. The Ryzen CPUs also have some advantages over the K. They have a much higher clock speed than the K6, which means that they can process more data per second. They also have more cores than the K6, which means that they can handle more tasks simultaneously and run more efficiently in multi-threaded applications. The Ryzen CPUs also support modern features such as 64-bit computing, virtualization, encryption, and SIMD instructions, which enhance their performance and functionality in various scenarios. In conclusion, the AMD K6 and FX-8350 were designed for different eras of computing and faced different challenges in their respective markets. They both had some strengths and weaknesses compared to their competitors and predecessors. However, they both pale in comparison to the modern Ryzen CPUs, which offer superior performance, efficiency, and features at competitive prices. How modern Ryzen CPUs improved on the architecture, performance, and efficiency of their predecessors. In this section, we will look at how AMD's Ryzen CPUs have improved on the architecture, performance, and efficiency of their predecessors, namely the AMD K6 and the FX. These two CPUs represent different eras of AMD's history, and show how far the company has come in CPU development. The AMD K6 was launched in 1997 as a competitor to Intel's Pentium II. It had a 0.35 micrometer lithography, 8.8 million transistors, 64 kilobytes of cache, and a clock speed of up to 233 MHz. The FX-8350 was launched in 2012 as part of the infamous Bulldozer family. It had a 32-nanometer lithography, 1.2 billion transistors, 8 megabytes of cache, and a clock speed of up to 4 GHz. Both CPUs had 8 cores, but the FX-8350 used a module design that shared resources between 2 cores, resulting in lower single-threaded performance. The Ryzen CPUs are AMD's current flagship products, based on the Zen architecture that debuted in the latest generation. Ryzen 5000 series uses a 7-nanometer lithography, up to 4.9 billion transistors, up to 64 megabytes of cache, and a clock speed of up to 4.9 GHz. The Ryzen CPUs have up to 16 cores, each with its own resources and capable of running 2 threads simultaneously. The Ryzen CPUs have improved on the architecture of their predecessors in several ways. First, they use a chiplet design that splits the CPU into separate dies connected by an interconnect fabric called Infinity Fabric. This allows for better scalability and power efficiency, as well as easier integration of different types of cores and memory. Second, they use a microarchitecture that optimizes instruction execution, branch prediction, prefetching, caching, and memory access. This results in higher instructions per cycle, IPC, and lower latency. Third, they support advanced features such as simultaneous multithreading, SMT, precision boost overdrive, PBO, auto overclocking, AOC, and smart access memory, SAM. These features enhance the performance and adaptability of the Ryzen CPUs to different workloads and scenarios. The Ryzen CPUs have also improved on the performance and efficiency of their predecessors by a huge margin. To illustrate this point, we will compare the Ryzen 7950X, a 16-core CPU with a base clock of 3.5 GHz and a boost clock of 4.7 GHz, with the K6 and the FX. According to user benchmark, the Ryzen 7950X has an effective speed of 88%, while the FX-8350 has an effective speed of 61%, and the K6 has an effective speed of less than 1%. This means that the Ryzen CPU is about 45% faster than the FX CPU, and about 910 times faster than the K6 CPU. In terms of gaming performance, the Ryzen CPU can run most modern games at high settings with smooth frame rates, while the FX CPU can run some games at medium settings with playable frame rates, and the K6 CPU can barely run any games at all. The Ryzen CPUs are also much more power efficient than their predecessors. The Ryzen 7950X has a TDP, thermal design power, of 105W, while the FX-8350 has a TDP of 125W, and the K6 has a TDP of around 20W. This means that the Ryzen CPU consumes about 16% less power than the FX CPU, and about 5 times more power than the K6 CPU. However, considering that the Ryzen CPU delivers about 45 times more performance than the FX CPU, and about 910 times more performance than the K6 CPU, it is clear that it has a much higher performance per watt ratio than its predecessors. In conclusion, AMD's Ryzen CPUs have improved on the architecture, performance and efficiency of their predecessors by leaps and bounds. They use a chiplet design that enables scalability and flexibility, a microarchitecture that boosts IPC and reduces latency, and advanced features that enhance performance and adaptability. They also deliver much higher performance and lower power consumption than their predecessors. The Ryzen CPUs are proof of AMD's innovation and leadership in CPU development.